For the definite integral from 0 to 2, square root of 1 plus x squared dx, find the left-hand sum and the right-hand sum using a subdivision of the interval from 0 to 2 into 4 equal subintervals. So here n is going to equal 4. Delta x is b minus a over n, which is 2 minus 0 over 4. And that's going to be 1/2. So if we're looking at the left hand first, we have to start on the left. The left will be 0. So this is the idea. You cut this by 1/2, or you jump by 1/2. And the left hand you start over here. So you start at x equals 0 first. And the base, delta x is 1/2, so I could just factor out 1/2. And I'm starting at x equals 0, which is 1. Now I jump to x equals 1/2. So you have the square root of 1 plus 1/2 squared, plus I go to x equals 1. That's going to be square root of 2. And then finally I'm going to go to 3/2, which will be 1 plus 3/2 squared. Now for the right hand, I'm going to start at the right here. So I'm going to start at x equals 2. So that's going to be the square root of 1 plus 4, which is 5. And then I'm going to go to 3/2, which is 1 plus 3/2 squared. And then I'm going to 1, which is square root of 2. And then to 1/2. That's square root of 1 plus 1/2 squared. Okay, next question. Estimate the area of the region under the curve of f of x equals 1 over the square root of 1 plus x squared over the interval from 2 to 5 using 3 equal subintervals. So n is going to equal 3 here, and we want the left sum and the right sum. So this is another way of saying estimate the area from 2 to 5 of this function. So delta x is b minus a over n, which is 1. Start at 2, jump by 1 to get to 5. So for the left hand, we're going to start on the left here. We're going to factor out delta x, and then we're going to plug in x equals 2. And then we'll go to x equals 3. And then x equals 4. So we have 3 rectangles here, and we stop. For the right hand, we're going to start on the right here. Factor out delta x. So we plug in x equals 5, it will be 1 over square root of 26. Now go to x equals 4. Then it's 1 over square root of 17. And then plug in x equals 3. That's 1 over square root of 10. Okay, the next question, we want to find the general antiderivatives. So we have the integral of 5 sine x minus 1 over 4 cosine squared minus 8 square root of x plus 7 over x dx. I'm going to rewrite this. 1 over cosine squared is secant squared. And then square root of x is just x to the 1/2 power. The antiderivative of sine x is negative cosine x. And then the antiderivative of secant squared is tangent. Now, for this one, we're going to add 1 to the exponent and multiply by the reciprocal of the exponent. And 7 over x is just 7 ln of x. Let's just simplify. The only thing we really have to simplify is 8 times 2/3, which will give us 16 over 3. And this is my antiderivative. Next one was the integral of x cubed times x squared minus 4 over x to the 4th plus x to the 4th over 4. So I'm just going to have to distribute the x cubed to all those 3 pieces. And then integrating, we get x to the 6th over 6, 4 ln of x, and then plus x to the 8th over 32. You have the integral from negative 4 times 5 to the x plus 7 over root x plus e. I'm going to rewrite this as 7 times x to the negative 1/2. And now this will just be negative 4 times 5 to the x over ln of 5. And then we're going to add 1 to the exponent and then multiply by the reciprocal of the exponent. E is a constant here, so the antiderivative of constant is just a constant times x. So this becomes negative 4 times 5 to the x over ln of 5 plus 14 times the square root of x plus ex plus c. Now we want to use the fundamental theorem of calculus to evaluate the following integrals. You have the integral from 1 to 3, 4 over t squared minus e to the 2t dt. So I'm just going to rewrite these as 4t to negative 2 power. And then from there, I can use the power rule. It'll be 4t to negative 1. And then you multiply by the reciprocal of the exponent, which is a negative 1. And then e to the 2t over 2 from 1 to 3. We have negative 4 over 3 minus e to the 6 over 2 minus, and then we have negative 4 minus e squared over 2. So negative 4/3 plus 4, let's see, 4 is the same thing as 12/3. So it's basically 12/3 minus 4/3 is 8/3. You have minus e to the 6th over 2 plus e squared over 2. Okay, next one is the integral from 1 to 4. 1 over the square root of t minus 4t cubed dt. So this will just be t to the negative 1/2 rewritten. And then we add 1 and multiply by the reciprocal of that. And that's going to be minus t to the 4th from 1 to 4. We plug in 4. The square root of 4 is just 2. And then 4 to the 4th is 256. Plug in 1. This is going to be 1. So it's 4 minus 256 is negative 252. Minus 1 is negative 253. Suppose that f and g are continuous and that the integral from 2 to 5 of f of x dx is equal to 4. Integral from 5 to 12 is negative 3. And the integral from 5 to 2 of g of x is equal to negative 7. We want to evaluate the integral from 2 to 12, f of x dx. So that's just going to be the integral from 2 to 5 and then 5 to 12. So you just broke this out into two pieces. Now 2 to 5 was given to us as 4. 5 to 12 is negative 3. So that's just 1. Okay, and then from that, let's find integral from 2 to 5. 4 times g of x plus 3 times f of x dx. So let's see. This will be 4 times integral from 2 to 5 g of x plus 3 times integral from 2 to 5 f of x dx. We know the integral from 2 to 5, or sorry, 5 to 2 g of x dx is negative 7. That means from 2 to 5, it has to be positive 7. So this thing is 7, and then this thing is given to us as 4. So it's just 4 times 7 plus 3 times 4. So 28 plus 12 is 40. Now the graph of e to the x squared is it? Yeah, y equals e to the x squared is symmetric about the y-axis if the integral from 0 to 3 of e to the x squared dx is a, and the integral from 0 to 5 of e to the x squared dx is b. We want to find the integral from 3 to 5 e to the x squared dx, and the integral from negative 3 to 5 e to the x squared dx. Okay, so for this one, we're just going to take the integral from 0 to 5 and subtract it with 0 to 3. So 0 to 5 is b, 0 to 3 is a. So that's this integral. Now for this one, we're going to split this up from negative 3 to 0, e to the x squared dx, and then from 0 to 5. 0 to 5 was given to us as b. This area is going to be the same as the integral from 0 to 3. And the reason is because this is symmetric about the y-axis. So if I were to say, okay, let u equal negative x, du will be negative dx. So you basically have, if x is 0, u is 0. If x is negative 3, u is 3. And so this would flip as integral from 0 to 3 e to the u squared du, which is exactly what I have here, but instead of x, I have u. Or instead of u, I have x. So they're the exact same value, and so this right here was given to us as a. So the answer is a plus b. Now, finally, we want to evaluate the integral from negative 5 to 5 of the square root of 25 minus x squared by interpreting it in terms of the areas. So this is a semicircle with radius 5. So the area was going to be 1/2 pi r squared. The radius is 5. So this is just going to be 25 pi over 2.